This is your Srinivas. Today topic is Hadoop and ecosystem. In this topic, we're going to discussing about the Hadoop. What is Hadoop? Why Hadoop? Different versions of Hadoop and ecosystem. First, coming to the what is Hadoop? Hadoop is an open source framework developed by the Apache Software Foundation for storing, processing, and analyzing the large scale of data. That is nothing but a big data in a distributed computing environment. It efficiently handles structured, semi structured, and unstructured data using commodity hardware. We know that the big data is going to be is nothing but a huge volume of data is going to be gathering very fastly. It is difficult to process. To handle that such a data of data, we're going to using the Hadoop. Hadoop is primarily strength lies in its ability to distribute data and process tasks across multiple machines, ensuring scalability, fault tolerance, and high throughput for the massive data sets. Here, not only that, in this Hadoop, we are going to use in the HDFS, that is Hadoop Distributed File System. A file system is designed to store large files across a cluster and splits into the blocks. Defaultly, it is a 128 megabytes and distributes them across the multiple nodes. It is going to providing the fault tolerance through replication. That is defaultly three replicas for the each block. That is we are going to maintain the three duplicate blocks, and we have the map reduce, a program model for processing a large data set in a parallel, divides tasks into the two phases. One is the map, another one is reduce. Right in the map, the process input data and produces the intermediate key value pair. Here we have the two things. One is the key and value. Together, it's going to be a pair in a map. We are coming to the reduce. Aggregates and processes the intermediate data to generate output. For the generation of the output, we are going to use in the reduce. For the input, we are going to use in the map. In that, we have the key and value pair. And we have the yarn. Yarn is an at and the resource navigator, a resource manager layer that allocates the computing resources and schedules the task for execute across a clusters. Clusters means here the group of machines or group of nodes we can say. Hadoop commonly provides the core utilities and libraries needed by other Hadoop components. This is about the what is Hadoop and what key components will be involved in the Hadoop. Next is why Hadoop. Hadoop is widely adopted for big data applications due to the following advantages. First one is scalability. Here, the Hadoop scales horizontally. You can add more community hardware nodes to the clusters as data grows. So it is going to be adding the more nodes whenever it needs to grow up the data and handles petabytes or exabytes of data with ease. Coming to the cost effectiveness, it utilizes the inexpensive off the shelf hardware, reducing cost compared to traditional systems. It is an open source software, eliminating the license free, false tolerance. Data is replicated across multiple nodes in HDFS, Hadoop distributed file systems, ensuring that data available even if a node fails. If in the one system node, the data is corrupted. We can access from the another node. Why means we are going to be keeping the data in the replication. Multiple times we are going to be storing the same data in the multiple nodes. Task running on failed nodes are automatically reassigned to healthy node by earn. So how it is going to be assigned to the new node means by using the earn technology, we are going to be connecting automatically to the healthy nodes. Flexibility supports multiple data types like structured data, semi-structured data, and unstructured data. Can ignite the data from various sources like log files, relational database, and social media, etc. Throughput, high throughput, optimized for high speed processing of large datasets through parallel processing. And how it is going to be handling means handles the batch process of data efficiently. And their data will not be streamed, it is going to be taken as a batch process. Next one is wide ecosystem. Here, why we're going to talking about wide means here we're going to be using the different integrated tools in the ecosystem. The Hadoop integrates with the tools like Hive, Pig, HBase, and Spark to enhance its functionality. These tools allows the querying, real-time processing, and data warehousing. This is about the why Hadoop is needed. Next, coming to the Hadoop versions. Yeah, totally we have the four versions: initial version, starting version, standard version. Let us see that we have the Hadoop 0.x first one. That is a not standard one, started version. After that, the standard version is Hadoop 1.x. Next, we have the Hadoop 2.x. Next, Hadoop 3.x. The first it was released in the year of 2011. Hadoop 2.x will release in 2012. Hadoop version 3 is released in the year of 2017. Here in the Hadoop version, first version, they used the HDFS and MapReduce techniques to handle the data. Whereas coming to the Hadoop 2.x, they included the AND in the version 2. In the Hadoop 3.x also they have the HDFS, MapReduce and AND. Here in the 1.x, Hadoop 1.x, they used the single name node. While coming to the Hadoop 2.x, they used the active name node and standard by name nodes. While coming to the Hadoop 3.x, they use the multiple active name nodes and standard name nodes. In the Hadoop 2.6, the manual intervention for the name node recovery. If is there any problem occurred, it can be recovered by the manually. Whereas in the Hadoop 3.x, no manual intervention for the name node recovery. Automatically, it is going to be recovering the name node. And in the version 1, we have the up to 4000 limitation of the nodes, whereas for the version 2, it is a 10 supports up to the 10,000 nodes, whereas for the version 3, it supports up to more than 10,000 nodes here. In the version 1, there is a single tenancy. Here we have the multiple tenancies. In the Hadoop 3 also, we have the multiple tenancy. Here in the Hadoop 2.x, they're going to be using the HDFS, FTP, Amazon S3, Windows Azure Storage, blob files are going to be used in the Hadoop 2.x. Whereas in the Hadoop 3.x, all file systems including Microsoft Azure Data Lake File systems. That means whatever we have in the files, your techniques, HDFS, all will be available in the Hadoop 3.x. And here we are going to use the Microsoft Azure Data Lake File System also. And it supports the version 3 supports the GPU hardware also. This is about the different versions of Hadoop. Coming to the Hadoop framework or technologies, there are the several reasons behind this development of Hadoop framework. It is an open source platform and also programmed in Java. It is a linearly scalable and reliable and accepts hardware failures. It is a fault tolerant system. It is a particular platform for store and process the data amounts greater than the terabytes of data. It leverages a commodity type of hardware. That means we're going to be using the different systems as a nodes. It is a scheme on read or has data agility. This is the framework. In this, we have the virtual infrastructure, virtual machines, J2E containers. It will work on the operating systems like Windows and Linux. In the first, we have to integrate data integration part. In this, we are going to have the structured data will be handled by the scoop and eho. For unstructured data, Flumi and script for user for the unstructured data handled by the unstructured data. Chuva is user for the log data. Pentho and Talend ETL Knox Security AA. All these are the first step of the data integration. For each and every different data, we are going to use the different techniques. After that, we have the Hadoop handling the programming of map reduce, and we are going to use the Pig, Hive, Java, Perl. In the Hadoop framework version 1 and version 2, we are going to use in the map reduce Hadoop file system, distributed file system, that is HDFS, and ARN, that is a map reduce 2.0. We can call it as ARN as we will call it as map reduce 2.0 version. After that, we have the storage libraries, data libraries, metadata storages. For this, we're going to use in the different techniques like Parquet, HBase, Cascadeur, DataFew, Hair, that is in the cloud, Sentry, Nutch, Solar, Gorga, and MongoDB. These are the different technologies we are going to be using for the data storage and the data libraries and meta data storages. And for data visualization and execution development, we are going to be using the H catalog, Lucene, Hama, Crunch. These are the different techniques are used for the data integration visualization. For the data serialization, we are going to using the Spark with the Avro and Thrift. In that, we have the data intelligence. That is, we are going to use the H2O, the drill and Mahout. For the data analysis with SQL, we are going to using the Impala, Spark, and Hive. In the by using the Flink. After programming skills, we have the managing and monitoring the architecture. We are going to use the Uzi. Uzi is the workflow, and we're going to use in the zookeeper for the configuring the entire setup. We're going to use in the provisioning. We're going to use the Ambari and CEDH for the user expensiveness. We are going to use the Hue, Nagios, Ganglia, monitoring, Splunk, Talent, Report, HDT and development will be used for the monitoring and as well for the giving for the security purpose. We are going to be using the Splunk and all these things. So we're having the three different things. One is for the data integration, data storing, handling of data, managing, monitoring, orchestration. And we have all these things will be run in the Apache. It is a platform ETL tool, platform functions, platform core units, data processing modules, data admin modules. So to process this, we're going to use in the data sets. We need the data sets by using the applying the algorithms. We're going to be showing the visualizations in the dashboard provided to the administration. Here we have the data core components like HDFS, MapReduce, yarn is the basic core components of the Hadoop. Essentials is pig. That is the pig Latin plus pig runtime, Hive or HQL. HBase it is came from the Google Big Table. Cassandra that is the Amazon's Dynamo, Avro, Zookeeper, Scoop, Mahout. Mahout will be used for the applying the machine learning algorithms. And we have the Hadoop incubators. Here we're going to use incubators will be used for the data injection layers and data analytic layers. Here we're going to use the Ambari, HDT, HCAT, Knox, Spark, Kafka, Storm, Smaza, Hama, and Hutch. This is the entire framework for the big data. Next, coming to advantages. Hadoop is a free and open source distributed storage and computational platform. It was created to allow storing and processing the huge or large amount of data using the clusters of community hardware. That is creating of the nodes. Here we have the structure. Why it is a helpful. We're trying to say that here we have the Hadoop distributed file system. It is a self-healing distributed and share the storage system. And that thing will have the three things. One is the shared storage, parallel processing, and distribution. Here we have the Hadoop kernel that the stored data will be sent to the Hadoop kernel with the parallel way processing by reducing map reducing function. Here the map will be distribute, aggregate, and collaborate. In the reduce, it is going to be processing the parallelly processing. In the map reduce, a batch query processing is going to be running. In the batch way, it is going to be sending the taking the input and processing the in the parallel way to give the output. Disadvantage: Hadoop is a generic processing platform framework designed to execute the queries and other batch reads operations on a massive datasets that can scale from tens of terabytes to petabytes in size. So it is going to be increasing the batch size. So it is difficult to manage that or scale that data. Coming to the history of Hadoop. In the 2002, Hadoop Notch is hand over the project and they implemented the Apache Software Foundation. After that, in 2003, the Google file system is existed in the 2003 by the Sanjay Yamhatwal et al. In the 2003, Nashville utilized their Google file system and improved that by distributing file system, converted to the distributed file system that is NDFS. In the 2004, the Google MapReduce came that they used the MapReduce paper written by the Jeffrey Dean and Sanjay from the Google. In the same year, Hadoop HDFS and Hadoop MapReduce came by the Don Cutting and Mike Cafrilla initiated the Hadoop Phase 0. In the 2004 actually got the Hadoop. Next MapReduce came with the new features by adding the few more points to the MapReduce. And finally, the first phase, the Hadoop project was formally launched with the name of Hadoop in the 2006. After that, in the same year, Hadoop made features development of Hadoop 2006. Yahoo is worked on the Hadoop platform and they introduced a few more concepts in the Hadoop. In the 2008, Hadoop became to the top level of ASF projects. After that, we got the Spark, GraphLab in the 2000 year with the cloud era joined. All the data is going to be stored and processed by the graph data and the Spark is going to be used in the 2009. And after 1 year in the 2010, the phase 2 was released with the Google license to ASF's Hadoop phase 2 by introducing the Hive, Pig, HBase, Flink. All these new concepts, new techniques is came in the 2010. After that, phase 3 was launched in the year of 2012 by introducing the Yarn, Storm, Kafka, all these things. After 2012, in the 2013 to 14, the ecosystem tools has going to be introduced for in the ecosystem tools with the new things. After that, Hadoop is the big data era by industrial backbone. All the industrial are using the backbone as a Hadoop in the companies to evaluate the or analyze the data by using the Hadoop technologies. Till now, we are going to manage in the services, all these things. After that, we got the challenges and evolution in the year of 2020 with the cloud native tools, and in the present, we are going to be concludation that the marketing process. That is about the history of the Hadoop. Here we can see that entire thing, history of the Hadoop. We started with the origin of the earlier inspections with the 2002 and 2003 with the Nutch project and the Google papers. After that, birth of Hadoop in the 2004 Nutch splits and 2005 HDFS renaming. In the 2006, Hadoop adopted that Hadoop. Yahoo is adopted the Hadoop. After in the 2008, the open source Apache Foundation came to release the Hadoop version 1. After that, mainstream adoptions that is Yahoo recorded and Apache Hive is came in 2010. 2010 in the same year, Cloud Era CDH launched with the cloud platform. After that, 2011 Hadoop 1.0 is released with the ecosystem. In the after that 1 year, the yarn was launched. The 2013 to 14 ecosystems, different tools is introduced in the year of 2013 to 14. After that, Hadoop in a big data era. After that, the industries are going to be started using the big data Hadoop concepts in the industries as a backbone and further managing the services. After that, it gives the challenges to store the huge amount of data. They worked on the cloud native tools. The 2001 to present, they, they are going to be marketing the consolidations of the Hadoop platform. That is about the history of Hadoop. Common aspects of Hadoop. As we see that, you can see here, initiator is the Don Cut and the Michael J. Cafrilla. predecessor is nudge, subsequent versions is yarn, or you can say that Hadoop 2.0. Hadoop written in the language of Java. Psychology of computations, divide and conquer for the large data sets. Philosophy of computation is divide and conquer for the large data sets. Here, the principles of computational processing is brings the computers to data rather than the brings the data to the computer. System, a distributed program is framework. Main characteristics are accessible, robust, scalable, simple, and for fraud tolerance. It is a storage Hadoop distributed file system, self-healing distributed and sharing the storage elements. Initial computation program is map reduce, distributed aggregation and collaboration with the parallel processing. Map reduce library written in the C++ code. Process type is going to process with the batches. Hardware type is heterogeneous community hardware for the node creations, clusterings. Software license is open source. Initial applications are IR and searching index and scroller. Solution type is software solutions, not hardware solutions. Scalability solution is scale out, not scale up. Type size of data is for a few GB to the few terabytes of data. Capable size of the data is forms tens of TBs to the few petabytes, terabytes to a few petabytes. Simple cohesive model is write once and read many times. Once we are going to write and reading them many times. Default replication factor is 3. Once the data is created, it will be duplicated in the 3 different systems. So when the system is failure means we can directly automatically connect it to the other 2 systems. From that we can access that information. Typical size of the data block for the HDFS is 64 MB. Permission model is relaxing POXY POSX a model. Main application models are Mahout, Hive, Pig, HBase, Scoop, Flumi, Shua, and Penthau is the main applications from the Hadoop modules. The typical vendors are MapReduce, Cloudera, Hortonworks, IBM, Teradata, Intel, AWS, Hadoop Amazon Web Services, Pivotal Softwares, and Microsoft. Right? This is about the Hadoop and Hadoop ecosystem and versions. I hope that you understand the what's the Hadoop and the basic concepts. Thank you.